Right, these are the answers for the mechanics assessment. First multiple choice, so the student throws a ball up in the air. It takes 6 seconds to go up and come back down, and it's thrown vertically upwards. We're trying to work out the initial velocity, so I picture this as being the ball going straight up, straight down. It takes 3 seconds, half of the 6 seconds to get to the top, and then another 3 seconds to get back down again. At its highest point, its vertical velocity is 0 meters per second. So we wrote our SUVAT letters. S, the displacement, we don't know, we don't care. U we're trying to work out, V is 0, A is minus 10 meters per second squared because it's going downwards, and T is 3 seconds. That's the time taken to get to the highest point. We're looking for a SUVAT equation which has U in but not S, which is V equals U plus AT. Sub our numbers in, rearrange, and we get to 30, which is answer C. Second one, work equals force times distance. This is working out calculating the work done by the car in 4 minutes. We know the force is 450 newtons. We don't know the distance. We do know the car goes 80 kilometers in an hour. So 4 minutes is 4/60ths of an hour. Oh, pardon me. So 4/60ths times 80 kilometers is the distance in kilometers the car will go in 4 minutes. Times that by 1,000 and that by 450, that gives us our energy, 2,400,000 joules, which is 2,400 kilojoules. The momentum question, the momentum before is mass times velocity. The momentum after is half of that, but minus half of that because it's going in the opposite direction. The change in momentum is the initial momentum minus the final momentum, so it's minus a minus, which is the same as adding. So we get a change of 1.5 mv, and because the ball, or the molecule in this case, I think it was an oxygen molecule, it was going to the left, now it's going to the right. The momentum has changed direction from left to right, so it will be a change to the right, 1.5 mv. Number 4 is D. So as the ball is falling, it's speeding up, but because the air resistance force is increasing and working against the weight, the acceleration is getting less and less and less and less, and when it hits terminal velocity the acceleration will be 0. But while the ball is falling before it hits terminal velocity, it's speeding up, but its acceleration is getting less. Question 5. The person or the student on the scales in the lift is moving at a constant velocity, so there's no acceleration, so there'd be no change on the scale reading. Because there's no acceleration, there'd be no resultant force acting on that. Number 6. So this is the hanging a painting in a frame. You've got 12 newtons acting downwards for the weight, but that's shared out between each side of the string. But the tension in the string is going to be 9 newtons all through the string. So we've got 9 newtons here for the tension in the string. We've got that side of the string taking half of the weight, 6 newtons, and that angle there is half of the angle we're trying to work out, because this whole thing is symmetrical and there'd be another side of the string acting down here. So if you work out that angle, its cos of that angle is adjacent over hypotenuse, 6/9. We rearrange this equation, so cos to the -1 of 6/9 is 48.2, and that's half of the angle we're trying to work out, so 48.2 times 2 is 96.4, which is answer D. Question 7, this is the tennis ball. So the momentum before is 0.2 times 15, the momentum after is 0.2 times -12. Minus because it's in the opposite direction, so we do one minus the other, and 2 negatives make a positive, so adding them together gives us 5.4 kilogram meters per second, which is answer D. Question 8. If the teacher's weight is 840 newtons, then the mass is 840 over 9.81, which is 85.6, and that means the scale reading is actually bigger than it should be, so that means the teacher must be accelerating, so it must be A, because if the lift is going down and they're decelerating, if they're decelerating downwards, it means they're accelerating upwards, so the scale is pushing up on the teacher as they slow down. Number 9, this is starting off with our kinetic energy equation, trying to write this in terms of momentum. So momentum P is equal to mass times velocity. So if we replace the mv squared, so if we square the whole of mass and velocity, that would be mass squared times velocity squared. Divide that by mass, it cancels out the squared on the mass, so it takes us back to half mv squared. So this is the important line here. So kinetic energy is half times mass times velocity all squared divided by mass, and we can replace the mv with p, so then we're left with half p squared over m, and timesing by half is the same as dividing by 2, so it's p squared over 2m, which is answer B. And the last multiple choice question, number 10, is probably the easiest one actually of the lot. The resultant force is going to be 30 take away 16, which is what, 14 newtons. The mass is 6, so using F equals ma, 14 divided by 6 is 2.3 meters per second squared, which is answer A.